Hello, everyone. Uh, so we are finally live. Thanks for joining in. Let me know if you can hear me. Okay, let's wait for a few minutes to see if people joining more. Till then, uh, let me know if you have any questions about Azure App Service. Uh, if you have any questions about it, if you want me to clarify something for you, or you have a specific use case scenario that you need to uh, that you want me to explain, just let me know. I'll surely check it on. Anyways, so I think we have few people who have joined in. We have like 5 users. So without delay, let's start it because this session will be recorded as well, and people can just go back and look at it at it once again. So my session, it's more about demo. I don't have any slides prepared. This is the only slide that I have right now. So we have like few different slides. I'm just talking about. I just have a topic on the slides, and I'll show everything on live directly without making it more theoretical. I'll make it more practical. So first, thank you all for joining in. I hope you guys. I hope you guys are watching it from home. I don't want you guys to be outside. I say stay safe. Uh, uh, this whole lockdown thing has been a very difficult time for us, but we need to be together in this so that we can get out of the situation and the mess. So in this scenario, in this session, we'll be talking about few different things in Azure App Service. So this is the agenda for the day. So I have agenda for scaling types, scaling patterns, scaling options in Azure App Service, cost of scaling in Azure App Service, metrics to consider for scaling, then demo and QA. So it's all demo, by the way. So there's no theory. But first, we need to start with scaling types. Even before that, let's talk about why do you need to scale. So, for example, if you have an application that has like that that serves certain customers or certain users in your system, it has a limited capacity that it can handle users too. So, for example, if you have an application that has like yep, sorry for the interruption. I got something in my end. So let's this sake. Yep. Anyways, so I was talking about the agenda, the application 200 users, let's say. So what happens if that user limit crosses? So for example, if your application starts getting more than 200 users, maybe 250, maybe 300 or something like that. So in that case, you need to scale your system so that it can handle the user request. and then you can, without any delay, so that the user won't face any delays or any interruption in the uses of application. So that's why you need to scale. But in a typical way, if you're talking about infrastructure as a service, or maybe let's say if you're talking about bare metal servers that you have hosted somewhere else in the office, or maybe you have a rent a big number of servers in quota, so that you can scale your applications to those servers in case of emergency, or maybe your number of users increases in the system. So uh, to avoid that, cloud computing gives you dynamic scaling options where where you can scale as much you want, as much you are required to scale, and you don't have to maintain all the hardware and all the systems at your end. You can leave that to Azure itself. So that's the benefit that the cloud computing gives you. And this is a very specific topic on cloud computing that we're talking about, but it's a very common thing that everyone needs. So we will be looking more deep into this. So first, let's talk about scaling types. So scaling types, as in what are the types of scaling that you have have as an option. So the first thing is you can have vertical scaling. So vertical scaling is like adding more compute resource to the same instance. So for example, if you have a server that has 8 GB of RAM and then 4 cores of processor that you can use to serve the application, in vertical scaling, you just go ahead and add more RAM, or maybe add more or upgrade the CPU type, or maybe upgrade the cores on the CPU. So that way, you can a limit on how much you can vertically scale. So maybe your motherboard can support only these GBs of RAM, or maybe you cannot add. You might need to restart your application that can create a downtime in the system. So in that scenarios, you don't want to do vertical scaling. You don't want to add more resources on top of on the same server and stuff. So what you can go to is you can go to horizontal scaling. So horizontal scaling is something where you can add more number of servers and replicate the application across the servers, and the application the request that the user will be served to uh, will be load balanced across multiple servers, so that you can use the same application across multiple servers, and then like have a large instance, and like have large compute resource. So for example, if you have a server that has 4 GB of RAM and 2 cores of processor, instead of adding more RAMs or more processors to the same instance, what you can do is you can add a second server, so that in total that gives you a new cluster of capacity, 8 GB RAM and four cores of processors. So and you can again add a third one, adding more compute resource. By in that scale, you can go as much number much of numbers that you want, and then like create new compute resources for your cluster. So that way you can also scale your applications itself. So this is a very common scenario that you do in both on-premise servers and then cloud computing scenarios. So horizontal scaling is something that we'll be talking about today. Uh, so first thing, so horizontal scaling. So these are the scaling types in Azure. But let's talk about scaling patterns. Like when do you want to scale, or what are the patterns that the applications or the business might need in case of in case of certain applications. So here is a basic documentation from Azure. So what it says is you can have a multiple patterns in the cloud that you can scale upon. So the first thing is you can scale based on the CPU usage. So for example, if your application is using more than 60% of your CPU, then you can say that, hey, if the application uses more than 60% of CPU, then just go and scale. So you can say that, and like the cloud computing platform will automatically scale the resources based upon the rules that you have set. So maybe you have set saying that if the application if the CPU percentage goes more than 75%, you can add a one more instance to the cluster. So it will look for certain minutes. So for example, it will look the metrics trend for 1 minute, and then it will, if it feels like, yeah, hey, this needs to be scaled, it will just go ahead and scale the application. The other way that could be possible is depending on the scenarios or depending upon the type. So, for example, your application ticket booking site for movies. So, in that case, the number of users will increase more on weekends than on weekdays. So, what you can say is, you can say like, hey, for this period of time, for Saturday and Sunday, scale my applications to 3 instances and make sure that it will handle the load for the user. And when it comes back to Monday, that is on weekday, like scale it back to 1 instance so that you won't be charged much. So you can do that as well. Or maybe you can say like, hey, do you I want for a specific time of a very very long time. So for example, uh, you have Dasai. So for example, let's say Christmas, Dasai, or any festival that happens. So in that period of time, the number of users might increase or decrease depending upon an application. So for example, if a application is a hotel booking site, in that case, the number of users will increase during the holidays. If your application is something else, then the number of users might decrease on holidays. So you can say like, for this trade, from this date, for maybe 1st of November to 15th of November, scale my application to 5 instances. But after that, scale it back down to 1 instance so that I want to charge more. You can set that rule as well. Or maybe you can have a custom metric on your system. So let's say you have an application which has a custom metric saying like the number of loan submission in your application. So say if the number of loan submissions increase more than 100, you can you can add a rule in the system saying uh, increase the number of instances to certain to, let's say, 5 or 6 or 7 or something like that. So you can say that. So this way you will get you can scale your application based on your need, and you don't have to worry about doing it manually. You can auto scale it however you want, depending upon the use case scenarios and your application. So these are certain few auto scaling patterns in the Azure App Service that you get. So let's talk about scaling options in Azure App Service. So if you're new to Azure, Azure App Service is a platform as a service offering that lets you lets you host applications in Azure. So Azure App Service is like a container where it hosts multiple applications. So let's see a small demo. Uh, so I have a app service plan called Livestream M29 ASP. So let me click on that. Okay. So so as you can see, this is an app service plan, and it has a certain compute resource that's been allocated to it. So the pricing tier is a standard one, and if you want to look that up, so the pricing tier is S1. So that gives you 100 uh, compute unit, and then 1.7 GB of memory, 75 GB of memory, and that will cost you $70 per month. But you get different options saying like 200 total Azure compute unit, or 3.5 GB of RAM, 400 total Azure compute unit, and 7 GB of RAM. So you can get multiple options on that. So this is just a plan that you get, and inside a app service plan you can add applications. So as you can see, there is one application in my case. So there is a demo application called Northwind Traders that I hosted for this particular demo. So you can have multiple applications as well. You can have 5, 6, 7, as much you want, but there is a certain capacity that the Azure App Service plan can hold. So it will alert you if you are hosting more applications in App Service plan that is very small. So it will check for the density of application that's inside App Service plan. So you can host applications based on the density that the app service plan allows. So for now, I have a app service plan that is 1.75 GB of RAM and gives me 100 as a compute unit. So I was running some load test. So there were some spikes in the CPU percentage and the memory percentage. So but in idle scenario, the CPU percentage is around 3%, and the memory percent is around 55 or like 60%. So it's a very normal trend for this particular app service plan. So what happens if the number of users increase? It could so if the number of user increase, it could increase the CPU percentage in an application, or it could increase the memory percentage in an application. So it really depends upon how you code and how what your application is. In my case, it's an application that actually, so that's a very generic application for a company called for a fake company called Northwind Traders. So let me show you what it does. Uh, Anyway, so sorry. So this is an application hosted in Azure. It's built on Azure. Sorry, it's built on .NET Core 3.1. The UI is on GitHub. The UI is on Angular. I just got this code from GitHub and I hosted it on my own. So there is some login scenarios, there is some registration scenarios, a very typical application that will get. So it has certain customers. So this is a list of customer that is coming from the SQL database. The SQL database is actually hosted at Azure itself. So it's a virtual machine that you get. So it's hosted on Azure virtual machine. The SQL database is there. So I can connect you and show you there what's going on the Azure virtual machine itself. So it's a virtual machine that has 7 GB of RAM and 4 cores of processors. Uh, so I'm just going to log into the. Yeah, I believe my streaming software just crashed. So anyway, sorry for that. I'm back again. So as I was talking about these this task manager shows the memory usage in the system. So it's a 7 GB RAM system where it is using 2.3 GB of memories. I'm just going to reply for some of one to the query. Anyways, so as I was talking, this is a SQL Server instance. So this app service plan is actually connecting to the this particular SQL Server. So let's see. So this is the code that I'm actually running. So and this is connecting by a very typical connection string, and then so yeah. So this application does nothing but just queries the database and gets you back. So gets you back some data back. So now let's see what happens if the user increases in this case. So currently I haven't set up any scaling auto scaling stuff. Uh, it will whatever it is right now. So it will do whatever it has right now. So that in this case it will just crash. So for example, if I run a if I run a load test in the system, it will just crash. So I have I have a load test for this particular stuff. So what I can do is let me show you the load test first. So the load test is just hitting a API and updating the database. So what it does is, for the first minute it will try and create the user for 200 user at a time. Then for the another minute it will remain, it will keep the 200 users as it is. In the third minute it will increase, bump up the number of users to 250, and then in fourth minute it will keep the number of users to 250, and then on the last fifth minute it will lower down the number of users to 170. So for now what I'm going to do is I'm just going to comment this out for now, uh, because I just want to show you what happens in this case when 200 users come to the system. So I'm going to run this particular load test. I hope my internet doesn't get clogged up with this, but let's see. So for this particular case, in this application, so I have set up the centralized logging for using application insight. For the application insight, so application insight is where you will get all the metrics for your system, all the logs, all the stuff that is happening in your system. So let me show you what's happening there. So I can go and click on live metrics. So the live metrics will show me the exact what's happening in the system right now. So as you can see, the load testing is running for a while now. So it's been running for 42 minutes, 42 seconds, and the metrics in the system just bumped up. So as you can see, the CPU percentage, the usage of system CPU in the system has been increased drastically. So it is increasing and increasing. It will just hit up to 100%, and it will go down after the test has been completed. So this is okay for small brush scenarios where the instance can handle the all of the load. But what happens if it is a regular load, and it will take like it clocks up the entire instance for like 10 minutes or maybe 30 minutes or 15 minutes. In that case, you'll have to go ahead and scale. So for scaling, what you have is you can have you have two options. So the first thing is you can scale manually. The second option is you can scale automatically based on metrics. So for now, what I'm trying to do is I'm going to horizontally scale this. If you want to vertically scale this, uh, you'll have to go ahead and scale up. In that case, that is scaling to uh, adding more memory or more compute unit to the same instances. But for now, what we're going to do is we'll be scaling it horizontally. So for the first option that you have is manually scale it. So that is you can increase the number of instances to maybe up to 10. So you can just click this and then just click on save, and it will automatically scale your application to another instance. But we are not going to do this. What we are going to do is we are going to set up an autoscaler. In that case, what happens, so autoscaler will look at multiple metrics or single metrics based upon how you set it up, and say, like, for example, hey, if the CPU percentage is more than 65, just bump it up to one more instance. So I can set that. So for now, what I'm just showing how the rule works. So it will get the data points of the application. So it will get the data points over a certain period. So for example, let's say you have a it will collect data for 1 minute, and it will average it out. It will average it out, or get take the minimum, or take the maximum, or get the sum, whatever you set it up. So but for now, let's talk about average. So it will get the data points for 1 minute. It will average it up. If the average comes more than 65 or whatever you set it to, it will say that, hey, this rule passed, this condition passed, and whatever it is it has to do, just do it. So in my case, it will take an average of 1 minute and see what is the CPU percentage. If the CPU percentage is more than 65 for a duration of 1 minute, it will increase the count by one. So it will increase the instance count by one, and then it will scale up the application. But this is a very aggressive scaling. This is just for the demo purpose. But what you should do is you should look for the metrics for at least maybe 10 minutes, let's say. So let's say for the in this, if you set it up to 10 minutes, it will look for the data points for 10 minutes and only decide if you need to scale or not. If you set that up to 1 minute, what happens is if you have a very normal spike in your system, let's say too many users come at the same time, it will take it as a very heavy load. Instead of that, you can just say like, hey, instead of looking for the 1 minute duration, look at the data points for 10 minutes and then calculate on top of that. But we don't have 10 minutes for this demo, so I'm just going to use 1 minute for now. And so in that case, what happens is if the CPU percentage average is more than 65 for 1 minute, it will increase the count by one number. So and the cooldown time is 1 minute as well. So the cooldown time is let's say it shouldn't be 1 minute in idle case, it should be maybe 5 or 10. So the cooldown period is something that the system will see again. So if the instance count has been increased by 1 minute, it will not try to increase the count once again for the another 1 minute or so if you put the cooldown time for 1 minute. So so that way you make sure that you are not increasing the number of instances like rapidly, because that will cause you some money. So you don't want to do this but for the demo purpose, I'm just putting it as one. So I'm just updating it and then saving it as it is. So so this will create a rule in my app service plan that says if the CPU percentage is more than 65 uh, for a time period of 1 minute, just scale it up to one more instance. So that's what I'm doing. Uh, so so now in this case, let's run the test once more. So I'm going to remove this comment. I'm going to remove this comment and then tell the system to pump it up, like add more, just hammer the application with more requests. So let's look at the live metrics as we do that. So I'm just going to run this load testing tool. That is called K6. I think it's like pretty awesome. You can take a look at that. So so yep. So this will initialize the engine and like ramp it up the number of requests in the system. So I think it will cross the limit of 1 minute. So it will cross the CPU percentage of around 100% as well. So let's see what happens. So the number of requests are being increased. The CPU percentage is increasing as well. So well, in the real world scenarios, I don't think your application will get this number of requests in a very drastic manner, but it could happen if there is a certain spike or there is a very unusual event that occurred. So you might want to like just be prepared for that. So as you can see, the number of CPU, the total CPU percentage is increasing as the number of requests increases in the system. So at certain point, it will just be stable because the number of requests will be stable. But at some point, it will just spike it up. So and it will slow down the entire thing. I really hope this particular load test won't slow down the stream. I think it will take a lot of bandwidth and it might slow down the stream. But just for the sake for the demo, I hope it goes well. But for the sake of demo, I hope it works. But if you see the SQL level, it's not doing anything. So the memory percentage is as much. It's like just 2.3. It's pretty stable. So in this case, your application is actually a very memory and CPU hungry thing. So in this case, your application needs to scale, not to database. So these are the things that you might want to consider in your application. So if if it's a database that's causing the problem, if it is a application that is causing the problem. So you need to be aware of that. You need to look at the logs. You need to look at the metrics and see if that's what is the thing that is causing the problem. So as you can see, the system is handling like 164 requests per second, and like the CPU percent is like 91 right now. So so it will take a while for this to be done. But for now, let's move to another topic for around 2 minutes. I'll talk about the pricing in this case. So we'll talk about the cost of the scaling in app service, Azure app service. So see, if you're new to Azure, you should know that it's the cost is according to whatever, how many hours that you use. So I'll just go and see for to the I'll just look at the Azure pricing calculator. So Azure pricing calculator is where you can estimate everything that goes into the system. So Azure, for app service, the the pricing is based on the number of hours. So the number of hours that you use and allocate the system. So in this case, the my system is hosted in Southeast Asia. Where it is, yep, Southeast Asia, and the operating system is Windows. My tire is standard. So see, the number of instances into number of hours that you use, that's equal to the price that will be billed for. For example, if you just use the instance for 500 hours, it will charge you based on that, so 50 hours. But in case of scaling, what happens if you scale to number of if you scale to 5 number of instances for 1 hour. So for those five instances for 1 hour, it will just cost you 50 cents, not more than that. So it's based upon the number of hours that you actually use. So what you should do is you should scale your applications to number of instances that you want, uh, and then scale it back down to number of instances that it is required to maintain the application state as it is. So for example, in morning you can have your application scale to only one instance, but in office time it can scale to 10 instances, but after office hours it can scale it back down to one instance. So you'll be only charged for one instance 10 instance for the 8 hours of time that you use it. So that would be $8 per month. Sorry, if that is if that is $8 per day. So in that case it will cost you $240 for those 10 instances that you use only during the daytime. So it really depends upon the number of hours and the number of instances that you use. So you the pricing depends upon totally depends upon that. So you need to take care of this. So anyways, so for now I think the test has been done. So yep. So I had said that like the request duration for the request duration should be at least 1.5 second, but the maximum request seconds was 3.06 seconds. So that means the performance of the application actually decreased. So instead of replying back the user at 1 second, it replied. So in some cases, it replied at 3 seconds as well. So that means your application has had some issues in the handling the request that comes in the system. So so it will take some time to kick in the scaling, and after even kicking in the scaling, it will take some time to create the instance and make it ready so that your application can be hosted. So it usually takes like 10 minutes to get it done, everything. So you should also consider that in your application use case. So for example, your system wants to handle a certain spike in the number of users. You want to be ready for that. You need some infrastructure ready for that. This auto scaling thing won't help you there, because it takes some time to get the metrics out of the app service plan. It takes some time to scale the application. It takes some time to create the infrastructure on the underlying infrastructure for it and host the application and manage the load balance and stuff. Even though you don't have to worry about that, it's everything is handled by the Azure itself. It has to you need to consider that in your application use cases and when you're architecting the application. So make sure of that. The auto scaling won't happen in a minute. It will take some time, 10 minutes, 15 minutes, or something like that. I hope it does. I hope it does this scale it as it is, scale as soon as possible. So I have set a email saying that if the auto scaling kicks in, send me an email. So as you can see, it says that autoscale has successfully started the scale operation for the resource this from capacity 1 to capacity 2. So in this case, it looked for all the metrics in the system for 1 minute, and then said like, hey, the CPU percentage is like more than 65 for like allocate it deployed my applications there, manage all the underlying infrastructure all for myself, and created a new instance. So as you can see, before it was one server, now I have like two servers running at the same time. So in this case, if I run the same load test scenario, I believe the performance will be pretty good. uh, I can show you that as well. So let's take a screenshot of this. Yep, let's take a screenshot of this, and then, or maybe I can just run in the new tab. I can just run in a new tab and like see what are the metrics that happen. So before it was for one particular instance, and the application was running only in one instance. Now it is running on two different instances. So we will be able to see some performance improvement as well. So so while it runs, let's move to the other agenda. So yeah, so the metrics to consider for scaling. So for the metrics to consider for the scaling, as I explained in the earlier case scenario, you can have anything that you want. You can scale upon the CPU percentage. Let me show you that. So you can add a rule. So you can add a rule, and you can you can scale on based on data in that comes into the system, data that goes out of the system, the disk queue length, the HTTP queue length, the memory percentage, the TCP metrics, something like that. So yeah, you can scale up purely based on that. So there are multiple things that you can do. Or if you want to scale, different scenarios. Let's say, for example, uh, you want to scale on a specific time. If you want to scale on a specific start date, if you want to scale out for a specific period of time, you can do that as well. Or maybe you can set a rule saying that just scale me these on Monday, Tuesday, Wednesday, Thursday, and Friday from so let me just set the time zone from 10 a.m. to 6 p.m. So you can set that as well. So what it will do is it will bump up the number of instances on these days for this period of time, and then you can have another rule saying that after after this time has been ended, bump it down to one number of instance. So let's say you can say Monday, Tuesday, Wednesday, Thursday, Friday. You can set it to maximum one. You can set it the maximum one, and then it will then say from 6 p.m. to next one day. Just when set the number of instances to one. So you can have multiple use case scenarios there. So it really depends upon you. So so yeah, this is it. Demo I have been demoing for a very long time, but this is what I wanted to explain you. So see, before having one instances, the CPU percentage was skyrocketing to 100% at all the time. But now it's and the two of the instances is handling the same load. So the CPU percentage for entire system is like 50% at a time. So it's like a quite good metrics. So it's handling quite well. So so it will still take 2 minutes to run this whole test. But for now, do you have if you have any questions, just let me know. You can add it that in the comment. I will try to explain it. There is a lag between my stream and how, like, when you see it, so it's like 15 to 20 seconds a lag in between, so I might be quiet for a while. But if you have any questions, just let me know. You can add that in comment. I'll try to answer it. Or if you have any questions related to ads or anything .NET related, I can answer that as well. But just let me know if you have any. Till then, I'll just wait for your questions. If not, I might end this stream after this test has been run, so that and we look at the metrics. It's another 1 minute to get this done, but let's see. So I'm bumping up the number of requests in the system, but the application is still performing pretty well. So this is why you need to scale applications in order to handle all the requests that comes in the system. By the way, if you want to use if you want to use K6, it's a very nice tool. Just look it up in Google. It's a very nice tool for load testing and stuff. So there is a question from Geeta Gurung. She's saying that which language to use in cloud computing. So see, cloud computing is a service that you get. It's a service that provides you compute resources without you having to worry about it. You can program your applications in any language that you want. uh, it could be .NET, it could be Node.js, it could be Python, it could be PHP, anything. You can just host it there. So it is not a language specific thing. It's not a programming language. It's not a framework or something like that. It's a place where you can rent service space and you can have compute resources there instead of having it in on-premise stuff. So it really doesn't matter which language you use. So it's a language agnostic. So it depends upon you and your application use case. So that's it. So yep, I think the test has been run. So see, after scaling the applications to 2 instances, the max time it took to respond to the request was 2.3 seconds instead of 3.06 seconds. It might look like just a second, but see, if you're serving a very large user group, let's say thousands, 2000s, 5,000 and stuff, these small metrics does matter, because you don't want your users to be waiting in the system, and because of a slow performing system. So scaling really helps there. So yep. So this is it. I think I covered everything that I wanted. So there's a question from Anand Karna, sorry. Can such scaling be implemented in open source portal like uh, WordPress or Moodle? I hope WP is WordPress. So WordPress and Moodle. Okay. So WordPress, yes, you can scale it. You can scale your applications in WordPress as well. Moodle, there might be guides that the Moodle provides, in case you want to have a scaling system. So it really depends upon the framework, but as far as I know, most of it provides it. So WordPress, yes, you can do it. I've done it. I've seen people doing it. Moodle, you'll have to look in the documentation and see what are the things that you need to take care if you want to scale Moodle application. So it really depends upon the port platform itself. So in case of Moodle, it might be the database that you need to take care of. It might be the application that you need to take care. So it really depends upon the library itself. Sorry, the framework itself. So you have to go and look into the documentation in it and see what are the things that you need to take care of. So there is a question from Abhishek Gomagai. What are the chances of auto scaling failure? If that happens, is manual scaling the only option? So auto scaling failure is something weird. Yes, it can happen. The auto scaler might not kick in, uh, and then your application might not scale. Yes, that could happen. In that case, what you do is you go ahead and create a alert in your metric system. In this case, application inside. You just go there and create a alert saying that if my application is still performing very badly, so even after setting all the rules of after setting all the auto scaling rules, even if my application is performing very badly, the request time is very high, the cpu percentage is very high, the memory percentage is very high, give me an alert. In that case, it will give you an alert. You take that alert and then go ahead and scale it manually. So there's a very low chance of happening, but if you want to be covered on that case as well, just go ahead and create a alert in your metric system as well, and it will notify you when the auto scaling doesn't work and your system is still performing badly. So that's how you handle it. That's a pretty good question, by the way. Yeah, I think it's like 1 hour of stream that we did. So it was pretty good. Yeah, I had some technical issues. I was almost about to cancel this because my system wasn't performing well, but somehow it pulled off. So I'm thankful for that. But uh, yeah, so I'll be providing this video can be still viewed as at the same link. You can still watch it. Uh, and I might have another video that explains the same thing in a very in a different flow and a scripted flow, so that you don't have to worry about the stream not working and system slowing up and stuff. So you can just wait it for wait watch a 10-minute long video instead of sitting on a 1 hour stream. I might provide that as well, but I'm planning for a stream every week, maybe twice a week. But this is it for the day. I hope you guys liked it. Just let me know what did you think of it. You can email me as well. If you have any suggestions for this stream, if you had any trouble watching this stream, or maybe if you have any suggestions for it, just let me know. And yep, stay safe, stay at home. Don't go out unless it's an emergency. But I hope this whole crazy scenario just goes by very quick. After that, we'll again do uh, offline stuff. But uh, but for now, I'll take a leave. And there's a last question from Ida Riza. Can you also share around the resources you talked about? Yes, I'll add the link of the resources that I talked about in the description of this video, so you can check it out and see if it works out for you. So I'll also leave my email and my social media accounts, so that if you have any questions, just let me know. I'll be very happy to answer. So, yep, that's it for the day. Thank you very much. Thank you for joining in. We'll see you next time. Bye bye.